If I'm solving two simultaneous equations, it means that I'm solving for two variables at the same time. So the first step that I'm going to do when solving simultaneous equations is I am going to label my equations. So I'm going to label them equation number 1 and equation number 2. Now, in order to use the elimination method, what we're going to do is we need to ensure that our coefficients are the same. All right, so the signs aren't important at the moment, just that the coefficient value is the same in the two equations. If the coefficient value isn't the same, then we're going to have to start by making it the same. In this case, it's the y that has the same coefficient, 4 and 4, and you can tell that the x's have different coefficients. Now with simultaneous equations, what we're going to do is we're going to work with the x's, the y's, and then the constants like that. All right, I'm going to look at this equation and I'm going to see that I can get rid of my y's. All right, so I want to get rid of one of the variables so that I can solve for the other variable. In order to get rid of these y's, I am going to add these two equations. So I'm going to say equation number 1 plus equation number 2. Why am I going to say that? Because if I said minus 4y plus 4y, that's going to cancel, that's going to give me 0. If I had said equation 1 minus equation 2, then that would be minus 4y minus positive 4y, which is the same as minus 4y minus 4y, which is negative 8y. So now what I'm going to do is I'm simply going to add these two equations together. So I'm going to say 9x plus 4x gives me 13x. Negative 4y plus 4y is going to cancel out, equal to 19 plus 20, which is 39. Now I can simply solve for the x. So I want the x by itself. So to get the x by itself, I'm going to divide the left-hand side by 13, but it's an equation. So what I do to the one side, I'm going to do to the other side. 13x divided by 13 is going to cancel and leave me with an x equal to 39 divided by 13, which is 3. Now I have an x value. So what I'm going to do is I'm going to take this x value and I'm going to substitute it into the equation. Now I could substitute it into equation 1 or equation 2. It doesn't matter which equation I substitute it into, but I'm just going to substitute x equals 3 into one of the equations. So I'm going to go into equation number 1. So if I look at equation number 1, it's 9x minus 4y equal to 19. All right, so all I've done is I've rewritten equation number 1 over here. All right, now I'm going to take the x value that we've just calculated or determined, which is 3, and I'm going to replace the x with that 3. So that means that I'm going to have 9. When I do substitution, I replace it with the 3, but I put it into brackets. Minus 4y is equal to 19. So now what you can see is that by using elimination, we eliminated the y first to calculate the x, and now we're going to use that x that we've just calculated in order to determine the y. So I have 9 times 3, which is 27, minus 4y equal to 19, and I'm just going to solve this like a normal equation. So to solve this, I would keep the negative 4y on the left-hand side, equal to the 19 would stay the same, stay first. This 27, when it goes across, would change from a positive 27 to a negative 27. So I would therefore have negative 4y equal to 19 minus 27, which is negative 8. But I don't want negative 4y, I want the y by itself. So I would divide both sides by the coefficient of the y, which in this case is negative 4, so that the negative 4's cancel. What I do to the one side, I'm going to do to the other side, so I have to divide the other side by negative 4 as well. So therefore, y is equal to, a negative divided by negative is a positive, 8 divided by 4 is 2. So now I have x being 3 and y being 2. If I look at my next question, I have 6x plus 3y equal to 48, 6x plus y equal to 26. So I'm going to start by just labeling my equation. So I have equation number 1 and I have equation number 2. So now what I have to do is I need to check my x and my y and see whether they have the same coefficient in the two respective equations. So I can see that this x in both of the equations have a coefficient of 6. So that is the same, which means that I can work with that. Alright, in order to cancel out those 6's, because I have 6x and I have another positive 6x, it means that I'm going to have to subtract them. So I'll say equation number 1 minus equation number 2. Remember, I have two options for elimination. I can either add the two equations together or I could subtract the two equations from each other. If I were to add the two equations, I would have said equation 1 plus equation 2. That would have given me 6x plus 6x, which would have given me 12x, and that's not what I want because that wouldn't have cancelled it out. So in order to cancel out one of the variables, I have to choose the correct operation. So that's why I'm going to say subtraction, because 6x minus 6x is going to cancel out. So now what I can do is I can subtract these two equations from each other. So I'm going to subtract the x's, I'm going to subtract the y's, and I'm going to subtract the constants. Alright, so 6x minus 6x is going to cancel out. Then I have positive 3y, and then this will become minus y, right? Because positive 3y minus y gives me 2y equal to, and then I need to do the constants as well, and I'm subtracting them from each other. So 48 minus 26 is going to give me 22. But I don't want 2y, I want the y by itself. So in order to get the y by itself, I'm going to divide 2y by 2 so that the 2's cancel. What I do to the one side, I'm going to do to the other side as well. So therefore, y is equal to 22 divided by 2, which is 11. Now I have a y value of 11. So I'm going to take that y value and I'm going to substitute it into either of the equations. So I'm going to substitute my answer of y equals 11 into, and I could go into equation 1 or equation 2, so I'm just going to go into equation number 1. So in order to go into equation number 1, what I'm going to do is I'm just going to rewrite equation number 1. So I have 6x plus 3y equal to 48. So I've just simply rewritten equation number 1 over there. Alright, so now I'm going to take this y value of 11 and I'm going to replace the y value with that 11. So I will have 6x plus 3 into, in place of the y in brackets, I'm going to put an 11 equal to 48. So I've just replaced the y with the y value of 11. So now I have 6x plus 3 times 11, which is 33, equal to 48. Now I'm going to take this 33 across. The 6x will stay on the left-hand side, equal to the 48 stays the same, stays first. The 33 now, when it goes across the equal sign, becomes negative 33. So I have 6x equal to 48 minus 33, which gives me 15. I don't want 6x though. I want the x by itself, so that means I have to divide by the coefficient. I'm going to divide by 6 so that the 6's cancel. What I do to the one side, I'm going to do to the other side. 6x divided by 6 gives me x equal to 15 divided by 6. I could write it as 5 over 2, or I could write it as 2.5, or I could write it as 2.5. But then I have an x value that corresponds with my y value. In the next equation, I have x minus 2y equal to 8, x minus 3y equal to 3. So now I'm going to start by labeling my equations. So I have equation number 1 and I have equation number 2. So I check to see if the coefficients are the same. If I look at my y's, I have a 2 and a 3, so that's not the same. However, if I look at my x's, then I can see that my coefficient is the same. It's a 1, but the sign is the same of the coefficient. So I have an x and an x. So I have an option of either adding the two equations together or subtracting the two equations from each other. If I were to add these two equations together, I'd say x plus x, which would give me 2x, and that's not what I want. I want to cancel out one of the variables so that I can solve for the other variable. So that means that I'm going to subtract these equations from each other. So I'm going to say equation number 1 minus equation number 2, and that's what's going to enable me to solve. Because now, if I cancel out the x's by saying x minus x, that's going to cancel out. But then I have minus 2y minus negative 3y, right? Because I'm subtracting the equations from each other. So that would give me minus 2y. This negative would jump into the bracket and it would create a positive 3y. So I'd actually have minus 2y plus 3y, which gives me my y. So I just wanted to show you where that was coming from. So I have minus 2y minus 3y, which is the same as minus 2y plus 3y, which is y, equal to 8 minus 3, which is 5. So now I have a y value of 5. So I'm going to take this y value of 5 and I'm going to substitute it into either equation. So I'm going to substitute y equals 5 into equation 1 or 2. So I'm going into equation number 1. So I'm going to rewrite equation number 1 as x minus 2y is equal to 8. Now what I'm going to do is I'm going to replace the y with what we said y is equal to, which in this case is a 5. So I'm going to have x minus 2 in place of the y. I'm going to put what y is equal to, which is 5, is equal to 8. X minus 2 times 5 is negative 10, equal to 8. And I'm going to now take this negative 10 across the equal sign. The x is going to stay the same, equal to, the 8 stays the same and stays first. The negative 10, when it goes across, now becomes a positive 10. So therefore, I have an x value of 8 plus 10, which is 18. So I have a y value of 5 and an x value of 18. So what that means is that if I were to take those values and substitute it into this first equation, so I substituted x is 18, y is 5, I'd get an answer of 8. Similarly, if I took the x is 18, the y is 5, and I substitute it into the second equation, I'm going to get the 3.